Back. We're back. Good, wait, going fast. Now we see that the 2dx is just sitting there, yeah? So now I will do the substitution. What do I end up with? Psst. I end up with antiderivative of?
Cosine u du.
Just cosine u du. And thus, I can now perform the antidifferentiation. The antidifferentiation, so what is the antiderivative of cosine u? Sine u. So the answer is sine u plus c. But then like the real answer is sine 2x plus c, which is what many of you just called out as being the answer like immediately. How are we doing? This is just a basic anti-differentiation problem. Say good?
Good.
Okay, now that I have...
To do the c. Like to do this problem we don't...
No, but in this box was me doing the thing called finding the antiderivative.
Okay.
Now I return to the integral problem. And the integral problem is to do this particular integral. So now we know via the FTC that to solve this integral, I just take the antiderivative of 2 cosine 2x, which I now know to be sine 2x, and I evaluate it at pi over 2 and pi over 4. Follow? And the FTC says that this is going to be sine of pi, sine of pi minus sine of, when I put pi over 4 in for x, I get pi over 2. And so this becomes sine of pi is 0, sine of pi over 2 is, or this minus 1, answer negative 1. Alright, are we feeling good?
Yes.
Okay, this is fine. I will call it like an acceptable way to do this problem, but it is like not ideal. A better way to do this problem is what I'm going to call option 2.
Option 2.
And option 2 is performing the substitution on the integral itself. This is called integration by substitution. And so I'm going to take the same problem, pi over 4 to pi over 2, and 2 cosine 2x of dx. But now, instead of taking this detour into anti-differentiation, I'm going to just manipulate the integral directly. What I would like to do is simplify this integral. And so I'm going to let u be 2x. Now, this is exactly like before. This is the same substitution that's going to solve both problems. But I think of what I'm doing now is a little bit different. And though I'm really just creating this new variable, you can sort of think of this as being like a function. I'm defining a new function u, which depends on x in a certain way. And now if I differentiate u, what do I get? 2. But this is just kind of a weird way of saying the same old, which is that du dx is 2. Okay? In other words, that du is 2 dx. Can you make sure this is on frame? So now well, was it in frame or not?
No. Not
okay.
you, but this is.
Okay, never mind. All right, good. So I wanted it all, but never mind. I wanted it all to be in frame if possible. Was I out of frame?
You were, but the writing is in frame.
But what was it like before?
That's what it was like before.
Okay, well, never mind. All right, good.
Okay.
Okay, good. I need to get a team of professionals. So now I perform the substitution directly on the integral. Because look, I still have 2 dx. So what I'm going to do is I'm going to replace this integral with. This is just u. This is just du. But now is like the moment of truth where we see if you understand what's going on. Because what do I do with these numbers? This pi over 2 and this pi over 4 thing. Can't use those numbers anymore. Because those numbers are x values. They tell me where on the x-axis to begin integrating and where on the x-axis to stop integrating. But what I am doing really, the real deep meaning of u substitution is we are like converting x values to u values. And this is the formula for the conversion. And so if I'm changing this function to a new function, then I need to go from the point that corresponds to pi over 4 on the x-axis. And that is like u of pi over 4. And u of pi over 2. Follow?
Follow.
Okay, and so now what that means is that I'm integrating from, what is u of pi over 4? No, careful. U of pi over 4 just says plug pi over 4 into the u equals 2x function. So this is just pi over 2, right? And this is pi. Okay, to convince you that, oh, should we just maybe, let me to convince you now that this is like reasonable, what I'm now doing, and I'm trying to have you sort of feel this graphically, what I'm doing now is I'm going to graph the cosine function, so this is 1, here's pi, but here's like 2 pi, and so this is like normal cosine now, right? So it's like that. Well, now I'm going from pi over 2 to pi. Well, what should this be intuitively? Also -1, right? Because it's half of a hump of the unmodified cosine curve. And what I'm really doing is I'm converting this entire integral into this entire other integral. And I'm doing that integral by performing the substitution on the integral directly. And when I do it this way, I don't go back. I only go forward. I now put this integral away. X is gone. And by gone, I mean gone forever. I don't substitute back. I now just have this simpler integral, and I just finish the problem with this simpler integral. How do we integrate this? You just use the FTC. What's the antiderivative of cosine? Sine. So this is just sine of u evaluated at pi and pi over 2. And what we get is sine of pi minus sine of pi over 2. And this is 0, and this is minus 1. So we also get -1. And the sort of big picture here is that this is like the x-axis. This is my 2 cosine 2x function. And this is the x-axis. And this pi over 4 and pi over 2 is where I begin and end on the x-axis. When I perform a substitution, what I'm really doing is like graphically sort of stretching by some factor this entire shape. And this axis is like the u-axis. Cool?
Cool.
And this is the corresponding one. All right, good. Let's do a problem. I do sort of need my notes a little bit. Grab a note. Ah,
We
here.
finished page number 1 yesterday.
Good. Woo! Okay, we're going to do this problem. This is a pretty hard problem, actually. Integral from 1 to 5 of x over root 2x minus 1 dx. Go.
Wait, which problem is it?
Just a problem I made up. To be perfectly honest, this takes about, 7 or 8 minutes to do this, but we got 1 minute. So let's go. I shall keep recording after the bell rings, and you guys all have a nice weekend. All right, what should we do first?
Substitution.
Do a substitution. Is there a particular substitution that seems like a really good idea here?
2x minus 1.
Yeah, let u equal 2x minus 1. And while this is same old, deep down, I'm going to think about this differently. I'm going to think about this as like a function that I'm defining, which takes x values and outputs corresponding u values. And I'm performing a transformation of the entire integral. Follow-ish? Okay, but anyway, if u is 2x minus 1, then what is du dx? 2. So du is 2 dx. Okay. Do I have a 2 in there?
No.
I do not. So I will stick in a 2, and I will undo the damage with a 1/2. But also that x is like a little bit of a problem, right? So that's what makes this like a kind of a relatively hard problem. What do I do with that x?
Ignore it. Write it in terms of u.
Yeah, Tekla says you got to do like a move, right? U is 2x minus 1, so that means u plus 1 is like 2x, which means x is just u plus 1 over 2. Okay, and now we return to the problem. So what I'm going to do right now is I got my 1/2 out here. This numerator, x becomes u plus 1 over 2. The 2 dx becomes du. The bottom becomes the square root of u. But now is the most important moment where we see if you're like getting this, which is that these numbers need to be changed. This 1 and 5 was tied to this x variable, but now I am making a new integral in terms of u. So what goes here is the corresponding u value. In other words, u of 1 and u of 5. Ah. Okay, so when the dust clears, I end up with 1/4, because I pulled that 2 out, times the integral from, what is u of 1? 1, and what's u of 5?
9.
9 of u plus 1 over root u to u. Alright, now we still have some work to do. We have to still do this whole integral. But does everyone sort of see how I have now, x is gone forever. I now just finished the problem on this integral. There's no subbing back to x's. Okay, how do we actually, I guess we have more time, let's go. 1/4, the integral from 1 to 9 of, I'll simplify this and write it as u over root u, which is u to the 1/2 plus 1 over root u, which is u to the negative 1/2. And now, do you know how to anti-differentiate u to the 1/2 and u to the negative 1/2? Yeah, it's going to be like 1/4 times what's the u to the 1/2? 2/3 u to the 3/2, and then this becomes like plus, go to 2 u to the 1/2, who's following this? Evaluated at 9 and 1, and now you just stick it in and you're done. Cool?
Yay!
Woo! I will finish on camera, or not. Maybe I don't need to finish. I'll finish. Alright, juniors, thank you. Sophomores, yeah.
That's exactly what I'm doing earlier.
Good luck on your AP exam that's already over. What is 9 to the 3/2? It's like 27, and that's 6, I mean, minus 2/3 plus 2, so whatever that turns out to be.
Yeah, we're gonna email you.
18, 21/4 times 24 minus
Email.
8/3.
Okay, Josie, I will see you later.
So
Maybe you didn't
that's
think you'll be back
something.
from walking.
72, I say 64/3. There's like a big chance this is like
Or
wrong.
we might just show up at your house.
It's okay, we're
I think that's just my parents' house.
I know, I just went pretty fast. 62, 72 minus 8, 64, 1/4, 9, 18, 24, 8/3. Maybe that's the answer, 16/3. Woo! Okay, goodbye, have a nice weekend.